Right, let's start with the revision day 2 discussion, starting with question number 30, right? Can we manage it? A car covers first half of a certain distance with a velocity of v1 and second half with a speed v2. The average speed during the whole journey is, right? Can you complete that question within 1 minute? Starting the time now. Average velocity is written total displacement divided by total time, like this, as constant velocity maintained, time is distance by velocity. Then average velocity is written 2s over t1, s over velocity first thing v1 plus this thing s over v2, right? Then average velocity becomes s cancel 2 over common denominator v1 v2 v1 plus v2. Then average velocity becomes twice of v1 v2 divided by v1 plus v2. Done, right? Within 1 minute we can complete this one. It's easy, no? Average velocity you should know, total displacement over total time. Done, right? Question number 31. Right, use 30 seconds to complete question number 31. Let's start. Enough time. With the constant acceleration in the 4th second, which means here 3rd second, here 4th second. In the 3rd second is this one, x1. Here, according to the question, here 3rd second. Then it should be here 2 second and 3 seconds. And 4th second is started from here. This is fourth second, right? Completed it. Yes, second completed. Start in the third second completed. Start in the fourth second completed. This one is S2, X2. They need the ratio of distance travel by it in. Underline in. Underline your tune, the term in. Underline it. In the second, which means they need X2 over X1. This could be the answer. We have S equal ut plus half at squared, ut 0, then short y. Distance covered in the given second is equal to half a delta t squared, right? This is constant. Therefore, basic theory, delta S directly proportional to delta t squared. Then x2 directly proportional to 4 square minus 3 square. x1 directly proportional to 3 square minus 2 square. This gives 4 plus 3, 7. This gives 3 plus 2, 5. Then answer is x1 over x2. Sorry, x2 over x1. Answer is 7 by 5. Correct answer is first one. Previous question, question number 30. Correct answer is fifth one. Okay. Done? Right. You should quick as possible, right? Okay. Question number 32. Can we have number 32? 32nd one. Can we complete this within 30 seconds? Quick as possible. They need, before coming to rest, it will travel a further distance of here to here 90. They need from here to here. Quickly. Non-stop, right? Yes. We got the equation. V squared equal u squared plus 2as. This deceleration to be kept constant. Then take this one into this side. It becomes v squared minus u squared equal 2as, right? This is called delta v squared as deceleration constant directly proportional to s. Here to here, 15 square minus 7 square proportional to 90. Then what about 7 square minus 0 square proportional to x? Divide each. 15 plus 7. 15 minus 7 equals 90. Here, 7 plus 0. 7 minus 0, it's 49 now. That's 49 equals to x, no? Right. Then find x. Take x. (25 centimeters). could be the answer. Correct answer is third one. Third answer is the correct. Okay, let's start number 33. Number 33. Body start from rest with uniform acceleration. Its velocity after n seconds is v. Then its displacement in the last 2 seconds is. Okay, right, give 2 minutes. Enough time. We need this one now. Then you can say delta S equal half A delta T square. Directly you can apply this one, right? So delta S is X, that's they need. Half acceleration A delta T means n squared minus n minus 2 before 2 seconds. Before before last second means n minus 2, as the overall time is n. Before 2 seconds later, before 2 seconds earlier, it should be n minus 2, right? Okay, that was squared. Okay. But we need A now. Finding A, we can apply V equal U plus AT. Done. V U0, starting from rest A becomes V over T. T is n. Right. We can put that value. X is half. A is V over n. Here n squared minus this one's squared value, no? N squared minus 2n into 2, 4n plus 2 squared 4, right? This is done. Now, then here we have v over 2n bracket n squared minus n squared plus 4n plus 4, right? Sorry, minus 4. Should be minus 4. Done. Multiple by minus into here minus. It becomes minus n squared minus minus plus 4n minus plus minus 4, right? These two cancel. So we have v over 2n. We have here common factor 4. It's n minus 2, right? N minus 1, sorry. N minus 1 clear. 2 into 1 here 2. Then answer is 2v n minus 1 over n. Do we have answer like this? It's 2v n minus 1 over n. Yes. Answer is first one. Right. Number 34. Right. Right. Read the question number 34. A body start from rest with uniform acceleration of 8 ms minus 2. Starting from rest. Accelerates by 8 ms minus 2. Time taken by it to transfer the second meter of its journey in second is second meter from here to here, first meter, and from here to here, second meter, right? Time taken by it to transfer the second meter of its journey in second is, they need the time gap of delta t right here to here, right? Just use 1 minute. Okay, complete now. Okay. Let the time taken from here to here t1, from here to here t2, total time, right? Then they need delta t. Delta t is t2 minus t1. Finding the time taken to cover t1. S equal half a t squared enough as initial velocity 0, s, first meter, half acceleration 8 time t1 square. T1 square is 1/4, right? 2, 1 here, 4 goes down. It's first one here, t squared. And t1 is, t1 square is 1/4. Then t1 is 1, 2, right, seconds. For the second, from here to here, total time is found. S is 2, half clear, acceleration 8, t2 square. No? Here 4, t2 square is 2 by 4. It's 1, 2. T2 is 1 over root of 2, done, seconds. Then they need the difference, time interval to cover second meter. Second meter is 1 over root of 2 minus 1 over 2, right? Do we have answer like this? No, right? We don't have that kind of answer. So what should I do now? Can we multiple 1 over root of 2 minus half by root of 2 and divided by root of 2, like this? So we have here root 2 divided by root 2 into root of 2 minus root 2 over 2 root of 2. No? Then we have here common factor 2. No? 2 is the common factor. We can take it out. It's 1, 2 available here. 1, 2 common factor. Then here 2 taken out, just 1. Then we have root of 2. After 2 is taken out, root 2, numerator, denominator, same value cancelled, it becomes 1, like this. This is the answer, but that kind of answer is not here, no? We don't see that kind of answer in question number 34. Then answer would be this one, right? Yes, second answer is the correct one. Okay, done. Can we complete the final answer? Right, completed, done. Then we have to start the first part of waves and oscillation, right? From question number 35. Let's start now. Define simple harmonic motion, right? First of all, you have to see here, right? Like this. If we consider motion, especially a symmetrical motion, right here, especially when we consider this kind of symmetrical motion around a point, that would be the midpoint of given drawn line, and respective extreme positions, let them A and the other end is B. If an object is going here and there from A to B and B to A and A to B and B to A across the center of the motion, and always object trying to transfer through the point of the center, an object always likely transfer across the center of O, that is called center of oscillation. If an object is moving across the center of the oscillation, center of oscillation or mean point, with the motion proportional to, motion means acceleration. This is having always acceleration concentrated towards the center of oscillation. Always in the simple harmonic motion, the acceleration is highly concentrated towards the center of oscillation. Then this equation is the basic equation of center of oscillation. This gives only the direction. We don't use this minus sign for any calculation. This is used to draw the graphs, identify the basic theorems, and derive the equation. We are using minus sign only. Then the motion across the center of oscillation, with the acceleration proportional to its displacement measured from the center of oscillation is identified as center of oscillation. Is identified as simple harmonic motion. All the simple harmonic motions should have those two properties. First one, it could have center of oscillation. Second, the acceleration, which is directed towards the center of oscillation, should be directly proportional to displacement measured from the center of oscillation. Those two properties are common properties for any kind of simple harmonic motion as well. Simple harmonic motion, always symmetrical motion. Either side acceleration equal in magnitude, but not the direction. Direction light like this, no? Therefore, acceleration at this side and this side definitely opposite. Therefore, acceleration won't be equal, right? Then basically acceleration towards the center of oscillation, but either side magnitude of all the physical quantities, displacement, velocity, acceleration, momentum, force, all the vector quantities getting equal, magnitude wise equal, but not the direction wise, right? Okay. Then this is the definition of simple harmonic motion. And at here, mean point now, at this position, we can say velocity of the particle is maximum. Velocity is maximum. And at here, velocity is minimum. Therefore, this point doesn't have kinetic energy. Kinetic energy is 0 at here. Kinetic energy maximum as velocity is maximum. Basic theory, right? Okay, then at here, we can call the maximum displacement occurred. Maximum displacement is identified as amplitude. These are the basic properties of simple harmonic motion. At the amplitude location, we have maximum displacement. Therefore, potential energy is maximum. And here, potential energy, AP, should be 0. Reason? X is 0. At here, displacement is 0. Therefore, no potential energy. But here we have maximum kinetic energy. This side also same. And at this position, acceleration to be 0. Center of oscillation, let's see, velocity maximum, but acceleration C. There is a 0 acceleration while having the maximum velocity. Example, if we have a statement like this, the velocity is maximum, the acceleration may be 0. Yes, correct. Example here. As well, when the acceleration here is maximum, A max, let's see, acceleration maximum, but velocity 0. We have a statement here. When the velocity becomes 0, it may have an acceleration. It huge acceleration, maximum acceleration offered, right? Okay, then, like that. And then here to here, time is called quarter of the period. Here to here time, from here to here and here to here, half of time period. Until here, 3/4 of time period. From here to here, complete periodic time is completed, right? Okay, these are the basic property of simple harmonic motion. And this acceleration is allowed as the direct equation for the calculations as well. In the simple harmonic motion, we can explain x equal a sine omega t. This is next one. This is basic second application. And when we consider circular motion made as the simple harmonic motion like this, if this is the center of oscillation O, particle goes like this, Particle goes like this in the simple harmonic motion. Then you can identify vertical displacement of this simple harmonic motion here towards this side, right? From here to here. And the particle is at another location right here. Vertical displacement changes like this now. And here it becomes maximum and it becomes amplitude equal to the radius of the circular path, right? Okay, then variation of this one here, if this is x, if this angle is theta, you know, this angle is called pace of vibration. Theta, pace of vibration. It's pace of vibration, right? Okay, then pace of vibration is made displacement from O, change of subtended angle from the starting point. Change of subtended angle at the center of the simple harmonic motion is called pace of vibration. Then we can say here to here distance is amplitude. This one is also amplitude here to here. But when we consider this rectangular triangle, sine theta is opposite base of hypotenuse. Then x becomes a sine theta. Then we all know that theta is angular displacement. Angular displacement according to the circular motion, and this is same as pace of vibration. Then angular displacement divided by time is angular velocity. So theta becomes omega t. Then we have x equal a sine omega t. This is the equation related to this one, right? And we can apply this one with this one. Then we have a equals minus omega squared. X is a sine omega t. Done. This is the next level application. Right. This is the basic function of simple harmonic motion. Then can we write question number 35? Define simple harmonic motion. Can we write to them? Simple harmonic motion. Write down. Motion across the center of oscillation. Motion across the center of oscillation. Center of oscillation with the acceleration towards the center of oscillation is directly proportional to displacement measured from center of oscillation is the simple harmonic motion, right? Okay. Then question number 36, write the basic functions of simple harmonic motion. For that, can we copy whole thing? This one. Copy instead of question number 36. Can we make this one? Okay. Can we check question number 37? Derive t equal 2 pi root of m over k for the periodic time of Helix spring of spring constant k and the suspended mass is m. Right. Can we use 2 minutes to complete that one? Question number 37. Can you complete now? We need to derive periodic time of simple pendulum is 2 pi root of m over k, right? First thing, we have to suspend the spring of constant k and suspended mass is m. First of all, it should be pulled down by a displacement of x and then removed. No? Then after this force is added, restoring force is created backward, right? Therefore, this is going towards backward just after the force is removed. But push is made away from the center of oscillation here. We have center of oscillation. This is center of oscillation here, first extreme position. This is the other extreme position, right? Okay, then we can say applying F equal ma towards the center just after the force is removed. Just after the force is removed. Okay, then F is the applied force. It is directed towards downward, but we have applied the equation towards backward. Therefore, we have minus sign. Equal mass is m, acceleration is a, right? Then F becomes kx, no? F is coming from kx. Placing kx instead of this F, we have kx minus function equal ma. Then a becomes k over m with the minus sign into x. We have to take this one, right, first. And we are going to equate this one corresponding to the basic equation of a equal minus omega squared x, right? Okay, then omega squared should be similar to k over m. Then omega becomes k over m root, right? Right. Can you drop this one? Until here. Now, Pute, from circular motion, from circular motion, we have omega equal 2 pi over t. Then equating both k over m root, similar with 2 pi over t, right? Then t becomes 2 pi root of m over k. This is the equation. Then t directly proportional to root k, t indirectly proportional to root del. T directly proportional to root k, t indirectly proportional to root del. Then we can draw the variation of t squared versus k here, m over k, no? Indirectly proportional to here k, here m, right? T squared versus m, and we can draw the other one, t squared versus k, and t squared versus 1 over k. Can you drop these three graphs too? මේ තුනත් ඇඳලාද? Right? T squared versus m, from this one, we can say here t squared equal 4 pi squared k into m. It's like y equal mx, right? T squared versus m is like this. T squared versus k, inversely proportional. Right angular hyperbolic curve. And for 1 over k from here, t squared equal 4 pi squared into m, 1 over k whole function y equal mx type, no? Then it should be again straight line. Okay. Let's see next one. Question number 38. Derive t equal 2 pi root of L over G for the periodic time for simple pendulum of length L and gravitational acceleration G. Gravitational acceleration G. To achieve this, we can draw the motion of simple pendulum halfway like this. From this one, right? Can you start to derive? Length of the pendulum is L, mass is m, we have weight here at an angle theta under the gravity of g. Here to here displacement is x. By covering those functions, can we derive that? Let's start 2 minutes to derive whole equation. Question number 38. Let's start. Right, derivation starts. First thing, we have to apply a force along this direction to take the object before release. No, we have to take this object before release. That force should be equal to tangential force given by mg sine theta. Then we have to apply F equal ma just after the applied force is removed. We have to write the equation just after the applied force is removed. Simple harmonic motion is operated only for this one, right? Not for this one. Only for F. Then applying F equal ma just after release the applied force towards the center of oscillation. Applied force is minus equals ma. F is equal to mg sine theta equal mass into acceleration. Mass cancel. Then we have A becomes g sine theta. Right. Now, we have to derive this equation by considering the small deviation angle. So, theta very small, then sine theta nearly equal to theta in radian. So, we have A equal minus g, sine theta is theta, then theta divided by, we can write here S equal r theta. S is arc length from here to here x. R is radius L, theta, angle theta, right? Then we have theta equals x over L, right? Then instead of this theta, we have A equal minus g into theta x over L, right? Then we have A equal minus g over L into x. Then the pendulum shows simple harmonic motion as A directly proportional to x. As well, you can say A equal minus omega squared x, no? Then omega squared equal to g over L. Then omega is g over L root, right? G over L root. Same as previous, omega equal 2 pi over t, equating both 2 pi over t, equate g over L, right? Root. Then t becomes 2 pi root of L goes up, g comes down, done. This should be the right. Complete this one. Right. Can we do question number 39 next? Derive V equal omega root a squared minus x squared for the velocity at a point of displacement x from the center of oscillation if the amplitude and omega, if the amplitude is A and, we have to write that one, right? If A is amplitude and omega is angular frequency. Okay, let's start now. For a simple harmonic motion, we have to derive B equal velocity at a point is this one, A squared minus x squared. Let's start now. Then we have to copy the straight line path of simple harmonic motion represented by a given object like this. If this is center of oscillation, O, here A, and here B, this is amplitude. At here, we can say displacement of X. Right. Now consider energy conservation at here and the considered other position. Energy conservation. Total energy at A, half K amplitude squared. Equation of potential energy of simple harmonic motion. It's better to use this one, right? Okay. Equate total energy at here, a part of kinetic energy plus part of potential energy offered. No, note down those two. Take this function into the other side, half cancel, no? K squared minus k squared equal mv squared, right? So we have k a squared minus x squared equal mv squared, then v squared equal k over m a squared minus x squared. Then v becomes k over m root a squared minus x squared root. Initially we got omega squared is k over m, right? Omega equal k over m root. Then instead of this k over m, we can apply that's omega. Therefore, we have a squared minus x squared. Done. This is the derivation. Done. Right, but from question number 42, 54, we have graphical arrangement. Graphs are very essential for simple harmonic motion. But if you can see the past paper MCQ question, for simple harmonic motion, around out of 3, we have 1 graphical question, right? Graphical questions, most of them in the past paper MCQ questions. Then can we do until 40 to 55? Okay, quick as possible, right? Before copy the graph, then derive the configuration of the shape of the graph at the right side space on the dude, right? Okay, starting from number 40. First, complete this one. Start from center of oscillation, right? Start. Draw the following graph for an object executing a simple harmonic motion. Can we write at the front position of simple harmonic motion? Lianna, from center of oscillation. Then all the graphs are started from center of oscillation. Okay, right. From center of oscillation. Right. Can you check first one, number 40? What's that? Displacement time graph. Displacement related with this equation, no? X equal A sine omega t. A remains same. Remains same. X directly proportional to sine theta, as this one is theta. Sine theta variation is a sinusoidal curve like this. This is the wave variation of displacement against time from the center of oscillation. Starting time is center of oscillation, clear. From here to here for one oscillation, right? For one oscillation. So this is the derivation. Can I have this one? If so, velocity time graph. In front of the question, we have a space to write the configuration, derivation for the shape of the graph. It must be the right? Okay. Okay, second one. V equal omega a squared minus x squared root. V omega remains same, constant. V directly proportional to a squared minus x squared root. Today, subtraction root never straight line. And we can say when x is 0 at the center of oscillation, when x is 0, V is directly proportional to amplitude, which means this one becomes maximum as A is the maximum displacement, X max is A as V is maximum. Then graph should be like this, no? Graph at the origin, when the time is 0, we have to assume the object lied at center of oscillation, maximum velocity offered, and then here maximum opposite direction, and here done. Next, acceleration time graph. Can you copy quick? That's acceleration time graph. Finish. It becomes A equal minus omega squared x. A directly proportional to displacement. Shape of the displacement would be same as the shape of the acceleration, but consist with opposite pace. Opposite pace. If this is positive pace, acceleration should be negative pace. It should be like this. If the displacement negative pace, acceleration should be positive pace. Opposite sign offered here, as the case of this one, right? Okay, then acceleration time graph, same as displacement time graph, but opposite pace. Like this for the, yes. And this is same as force against time. And this is same as momentum against time. And you are asked to draw number 43 momentum. It should be same as velocity time graph. And here, force, it is same as number 42. This is 44. Momentum is 43. Can you complete them? Until 44, clear. Now, can you draw the variation of kinetic energy, potential energy, and total energy against time? for simple harmonic motion. Against time. But before completing in the board, you have to complete. At least you have to draw the rough shape. Okay. At the center of oscillation, kinetic energy is maximum. At the extreme position, velocity 0, kinetic energy 0. Then at the center of oscillation, kinetic energy maximum, and there is no value, there are no any kind of values at the negative sign of energy graph. Therefore, this part is not considered. Then graph varied like this. Kinetic energy variation will be same as variation of velocity, isn't it, Pudha? Kinetic energy directly proportional to V squared. V is also curved one, then V squared definitely curved one, like this. Potential energy at the center of oscillation, 0. Graph started like this. Total energy remain constant. That is called energy conservation. Total energy remain constant. Can you note down here? Done, Buddha? Right. Now, we have to check 49 to 55. Right, let's start. 49 to 55. Forty-eight to onward. You have to copy the graph with the derivation, right? Not the assumption. Okay, number 48. Acceleration against displacement. Then you have to say A equal minus omega squared x. It's like y equal minus mx, no? It's like y minus mx. Y equal minus mx. Shape of the graph minus gradient passing through the origin. Done like this. Acceleration, displacement same as force displacement, as acceleration directly proportional to force. Same process. Next. Can we copy velocity against displacement? Number 50. Here you have to consider simple harmonic motion like this. Here center of oscillation. This one extreme position B, and here A. This and this, A and B. Okay, velocity variation. At the center of oscillation, velocity is maximum right here. Velocity is vector quantity. When it is traveling towards right side, if the velocity is positive, when it is turning back, velocity should be negative, like this. At the extreme position, velocity 0. This extreme position, velocity 0. Then velocity from 0 to maximum varied like this. When it comes from here to here. And from here to here, velocity decreases to 0. And from here to here, direction has changed. Then like this. This could be the graph, right? Specific graph for the unknown one for the past exam papers, right? Okay, new one with the star mark, right? Next, kinetic energy against displacement. At the center of oscillation, kinetic energy maximum. At the extreme positions, kinetic energy 0. This would be the variation. At the center of oscillation, potential energy is 0. both extreme positions, potential energy maximum. Potential energy varied with E equal half kx squared, no? E proportional with x squared. Kinetic energy directly proportional to V squared. Then V varied non-uniformly. Then kinetic energy varied non-uniformly. Potential energy is also varied non-uniformly as x is changed with the variation of curved one. E also same, right? Total energy remain constant throughout the entire displacement from here to that position. Total energy remain constant, right, Pudak? Okay. Then until 54, we complete, no? Okay, then let's start question number 55. It's simple question. Let's start. Number 55. A particle is executing simple harmonic motion of the time period 4 seconds, right? Write down that time period 4 seconds. What is the time taken by it to move from A, mean position to half of the amplitude, B, extreme position to half of the amplitude? Okay. Number 55. Can we draw a kind of simple harmonic motion to take an idea about the question? Here, center of oscillation. This is the amplitude A. Half of amplitude, it's A by 2. They need, what is the time taken by it to move from mean position to half of the displacement? Mean position to half of the displacement T. If the periodic time is 4 seconds, capital T is 4 seconds. Okay. Use 1 minute to complete this. Let's start. Okay. To find that time, we can use x equal a sine omega t. Then we can say x is a by 2, a sine omega 2 pi over t into t, right? A cancel, half equal sine 2 pi over t into t. Anti-sign of half means 0.5, no? Sine table half shows 30 degree. Here 30 degree represents anti-sign of this value, no? So this pi value should be entered in degree. Yes, pi equal 180, 2 pi is 360 degree divided by periodic time 4 seconds and the time of t here, no? Right, here 2 here 90, 30, 1, here 3. Then t becomes 1/3 of second. Time for the motion is 1/3. Then here to here overall time from O to A overall time is 1 second. From 1 second, 1/3 of second allowed from here to here. Then rest of here to here to here, it needs 2/3 seconds. Then from, let this point be, from O to B is 1/3 of second, and from B to A 2/3 of second from the whole journey. No? Yes, done. Then answer is this one. 1/3 of second and 2/3 of second. Okay. Let's start question number 56. If you didn't complete this one early, brother, quick as possible, you should write. Okay. That is simple thing, just using the basic applications of simple harmonic motion and how to simplify this kind of application. This is not in the past paper. This is newly made one. Then take this star mark for number 55, right? See number 56. The period of simple harmonic motion is 8 seconds. Find the ratio of distance traveled by the object in the first second and the second second. First second and the second second. Ratio of distance. Let's start. Right, complete that one within 1 minute. So they, after completing 1 second, it may have a displacement of x, right? After completing 1 second. But here to here motion is not symmetrical, right? Here to here motion is not symmetrical. Reason, they are having change in acceleration from here to here. Yes, decreasing acceleration available, right? Therefore, distance from here to here after 1 second, not a by 2. That's not fair, right? Okay, they need the ratio of distance traveled by the object in the first second. They need the ratio of x over 2 second a. They need x over a. They need x over a. Right. Then we can find x first. How? X equal a sine omega t. X is the value needed. A is a sine 2 pi over t into t. X becomes a sine 2 pi over t. T is 8-second periodic time, just after 1 second. Then x becomes a sine, majority we have pi. Pi is 180 by here 2, 4, no? Done. Then x becomes a sine 180 by 4 is 45. Sine 45 is 1 over root of 2. Then x over a is, x is a by root of 2 over a cancel, then x over a equal 1 over root of 2. This could be the answer. Okay, right. The ratio of distance after 1 second and after second should be like this. Then this answer is wrong, no? This won't be the answer. Reason? They have in the first second and in the second, right? In the first second, this one. In the second is this one. No? It should be a minus x. Then this ratio is wrong. Make a උත්තරේ වෙන්න නම් පුතා තියෙන්න ඕනි in the first second over after second. එක හදාගන්න එතනින්. Right. Can you rearrange? This one is another question. But they need in the first second and in the second a minus x, which means a over root of 2, a minus a over root of 2, no? A cancel. 1 over root of 2, here 1 minus 1 over root of 2. This could be the answer. Simplifying 1 over root of 2 over its common denominator root of 2. Root of 2 minus 1. Okay. Then root 2 cancel. It becomes 1 over root 2 minus 1. Read the question carefully. They need distance in first second, x. And distance in the second means after completing first second, starting the second. Second completed at here, then in the second is this one, right? Which means a minus x, done. Okay, right. Carefully, we have to read the question, right? This kind of MCQ question. Okay. Number 57. Let's enter the question. Number 57. Diagram is not mentioned. We have to copy the diagram too. Okay. Can you start now? Just use 3 minutes to complete this one. Okay. It's up and down moving platform, no, like this, by connected with the string, up and down. And down right here. Okay. If this is the center of oscillation, we can note here amplitude is 5 centimeter and lower amplitude 5 centimeter, right? Man stand on the platform of 60 kilogram. Okay. If the machine on the platform gives the person's weight against the time, find the maximum and minimum reading that will show. Right. This instrument may have this kind of reading scale. So this gives the minimum reading, R minimum here, as it is upper location and this is compressed down. This will read maximum reading. So the reading of the spring balance is the normal reaction. Can you note that one? This one is minimum value. Here, offered reaction is the maximum value as it is maximally compressed here. This is maximally relaxed. Relaxed position is the low reading. Compressed, maximally compressed position is maximum reading, right? Use another 1 minute to complete this one. Now you know the process, right? Let's start. Right. First of all, we can find maximum acceleration at here and here. Both having the same maximum acceleration, A max as the maximum displacement. Here, A max available, no? And I'm finding maximum acceleration equal omega squared x. We are going to take some calculation. During the calculation, we don't use the minus sign, right? Then maximum acceleration offered as maximum displacement. Then A max becomes omega 2 pi over 2 pi f. Here mentioned frequency, no? You are given frequency of the oscillation is 2 per second is hertz, right? 2 pi f to the power of 2. This is amplitude. Okay, then here 2 pi squared, 2 squared pi squared, frequency 2 squared. Amplitude is 5 centimeter, pi by 100, right? Okay, then 2 squared 4, pi squared let it 10, 2 squared 4, pi by 100, right? Okay, then 4 into 5, 20. 20 is to 1 0 cancel. This one is to 1 0 cancel. Here 8 ms minus 2 is the maximum acceleration. Say yes. Then applying F equal mv by labeling the weight of the object like this. Applying here F equal mv always towards the center of oscillation, as this acceleration is directed towards the center of oscillation. Then applying F equal mv, F here mg minus R max, R minimum, no? Yes, R minimum equal mass into acceleration maximum, done. Okay, then we have here 600 minus R equal mass 60, acceleration is 8. R becomes 600 minus 480, no? R is 120. Then R becomes 12 kilogram. The reading dropped to 12 kilogram. And here F equal ma towards the center of oscillation. Center of oscillation at the direction of R, no? Yes, then R max minus mg, as mg is opposite direction, equal mass into acceleration. So R maximum value is mg 600 plus 16 to 8. So maximum value of R is 1080, no? It's 108 kilogram is the reading. Okay. Copy this one. Right, number 58. Read the question carefully. Question number 58. A block is resting on the piston which is moving vertically. It's like this. Here we have block. It is vertically moving like this. And like this. And here we have motion of period 1 second. what amplitude of the motion will the block and the piston separate? What is the maximum velocity of the piston at this amplitude? We have two questions, right? Let's start now. Number 58. You have 2 minutes. Let's see the process for the enough time. At what amplitude does the block release? Then labeling the forces. Weight of the object is made towards the center. This is the normal reaction. At what displacement of the piston does the mass release, which means mass release R should be 0. Then apply F equal ma towards the center of oscillation. Towards the center of oscillation, we have mg minus r equal m a equal omega squared x, right? Then r becomes 0. That should be the maximum displacement. Therefore, this is a x max. R should be 0, right? You should know it, right? When the object flies, object flied off from the piston, then R should be 0, no, detach the object with the piston, then R 0. It's mg equal m omega squared, let this one a, cancel, g10. Here 2 pi periodic time mentioned, t that of squared a. They need a, no? You can find a now. 10 equal 4 pi squared over 1. 1 squared is 1, then a, no? Yes. Pi squared 10, you can cancel off, no matter. A becomes 1/4 of meter. It comes 0.25 meters. And at that instance, the velocity is omega root of a squared minus x squared as the maximum displacement location. Maximum velocity is made at here, no? This is the Vmax one. At here, x should be 0, no? X should be 0. So maximum velocity is like this. Then Vmax is omega 2 pi over t into amplitude. We got 1/4. It's 2 pi 3.14 divided by t 1 second of 1/4, no? It's about Vmax is 1.57 ms minus 1, which comes 3.14 divided by 2. Okay, done. $58 complete. See, 59. Question number 59. Let's start. Number 59, a particle is executing simple harmonic motion. What fraction of energy is kinetic when the displacement is half of the amplitude? What fraction? Fraction එක ගන්නේ total energy එකට. What fraction? Fraction is mentioned for total energy. Fraction is mentioned for total energy. Okay. Can we use 1 minute to complete? Okay, enough time. 1 minute's enough. Right. Let's see. At the extreme position, potential energy is maximum. At it should be written half k a squared, right? First one. Then potential energy maximum is same as kinetic energy maximum as well. All the points are having constant total energy. Then at here, maximum potential energy is same as total energy. Then total energy you can say half Ka squared, right? This is the total energy. Then we can equate this one, ET, right to the clear. And this position does have both half mv squared plus half k squared potential energy plus kinetic energy, right? And those two sum should be same as half k a squared. This whole one should be equal to this one, that is conservation of energy of simple harmonic motion. Then here you are given this one is the kinetic energy. Then put this value Ek and plus half K, x is a by 2, no? That of squared equal half K squared, right? Then take this function into the other side. Then kinetic energy becomes half Ka squared minus half Ka squared. Here 1 2 squared is 1/4. Then full value minus 1/4 value. It becomes 3/4 of half Ka, right? Half Ka squared. Done. This is kinetic energy. Can we put this value here? 3/4 of half Ka squared. These two cancel. Then kinetic energy Ek associated with the total energy becomes 3/4. This is your final answer. This is also MCQ question, right? Okay. If you finish this one, let's start number 60. Other guys, we have to write quick as possible and then enter question number 60. The speed needed now, right? This is not the theory class, right? Complete recovery one, right? This is not the type of revision one. This is recovery one, fast track one, right? To be quick as possible. Right, number 60. Read the question. Kinetic energy of a particle in simple harmonic motion is 4 joule when it passes through the mean position. Its mass is 2 kilogram. The amplitude is 1 meter. Calculate the periodic time. Okay. Right. They need periodic time. I think enough time, right? Okay, use 20 seconds. Use additional 20 seconds to complete this one. Kinetic energy at the center of oscillation equal half mv squared. E becomes 4 mass is 2, velocity is 2 ms minus 1. This velocity is the maximum velocity of this simple harmonic motion. As the mean position, only energy is kinetic energy, and that kinetic energy is a maximum value. So you can say V maxi equal omega squared A coming from V equal omega root of A squared minus X squared. Done. From this one, this is 2. Omega squared 2 pi over T. Amplitude is A. Two pi squared over, we need the period. If the amplitude is mentioned here, 1 meter. Done. Then we have square root of 2 equal 2 pi over T, right? Then T becomes root of 2 pi. T becomes 1.41 into 3.14. Right, pick the correct answer. Simple thing, right? We can do this one, like MCQ question. Okay, let's see number 61. If you complete this one, start 61. Okay, number 61. A simple pendulum of length 1 meter and 16 meter are in the pace at the mean position at a certain instant of time. Same pace, no? Are in pace. In pace is same pace at a certain time. Is it like this? 60. This is one pendulum of length 1 meter. The other one is about 16 meters, right? Oscillation is at the given instance, given time, let the time is t naught. Let the time is t naught. They are in the same pace. Same pace means same location, right? Same pace is same location. Right here, like this. At the vertical location, we assume like that, right? Okay, then if t is the time period of shorter pendulum, this one is the periodic time of t here, then find the minimum time after which they will be in the in pace again. In pace means same pace. Shorter time interval by oscillating several oscillations by this and this. This is slow one. This is faster one. By using shorter time interval, both the pace becomes equal. This is MCQ question, right? Use 2 minutes. You have to think about this. They are having the combination of periodic times, and then the pace should be same, right? Let's start now. Okay. If the periodic time of this one is t, periodic time of that one, first of all, we should write this one. T equal 2 pi root of 1 meter over g, and t dash equal 2 pi root of 16 meter over g, right? Divide each, this cancel, g cancel. T over t dash equal 1 by 16, no? Root is 4. Then t dash is here 40. If this one is the periodic time t, this one is 40, right? This one take t time. Example, if this is 1 second, this is using 4 seconds, no? Any kind of situation, this one is having the pace is written theta, no? Pace of angle, pace of vibration is theta. Theta should be equal to omega t, right? If you can remember, x equal sine, x equal a sine omega t. This is coming from basic theory. We have to by heart, right? This is the function, this is the final answer. Then theta is omega t. And this is having another kind of value of omega as different kind of pendulum. This one is having another kind of omega. Let this one omega t, and this one theta equal omega 2t. T is the same time interval. They are starting together. Then if they are having the same pace, time interval, which means this t should be same. Then this one theta 1, this one theta 2. They are coming to the same pace, right? If they are started with the pace of 0 degree, after a certain number of motions of either their number, then finally they should obtain the same pace. ඒ කියන්නේ පුතේ මෙයාගේ oscillation ගානයි number of oscillation of this one never equal, right? Number of oscillation of this one and number of oscillation of this one never equal when they are having the same pace at the second instant. First instance, they are having this location, they are oscillating, this is also oscillating, they are having different kind of periodic time. Then if they are having the same pace of vibration, they won't be having same number of oscillation, but they should have same pace. Then Pudha, if this pace is 0 degree, this one should be additional 360 degree completed. Or if this is 0 degree, this one should have additional 360 degree, which means omega 2t minus omega 1t should be equal to 2 pi. 2 pi is 360. දැන් එක්සාම්පල් එකක් විදිහට කිව්වොත් මෙයා ඉන්නේ මෙතන නම් යම් මොහොතකදී මෙතන නම් අරයා පුතේ මෙහෙම වටේ කැරකිලා මෙතෙන්ට ඇවිල්ලා තියෙනවා. හරි. ස්ටාර්ටින් ලොකේෂන් අපි නිකන් ගත්තොත් මේ වෙද්දි A කියන කෙනා මෙතන නම් ඉන්නේ B කියන කෙනා වටයක් කැරකිලා මෙතෙන්ට ඇවිල්ලා තියෙනවා. එතකොට තමයි same pace වෙන්නේ. පැහැදිලි? මේක මෙතන ඉඳලා මෙතෙන්ට කැරකිලා આવුත් සර්කල් එකේ half way ඇවිල්ලා තිබ්බොත් ඒක 180 pace එකක් වෙනවා. 3 ඒ කියන්නේ එකම pace එකට එනවා කියලා කියන්නේ එක්කෙනෙක් location එක මෙහෙම නම් අනිත් එක්කෙනා ගිහිල්ලා මෙතෙන්ට ඇවිල්ලා තියෙන්න ඕනේ. ඒ කියන්නේ pace difference is 360, which means 2 pi. Right. Note එකක් දාගන්න එතන. To equate the same pace, difference of pace of oscillation, pace of oscillation of short string and the long string. Short string and the long string should be equal to 2 pi. Okay, then we have here 2 pi over periodic time t into t. They need this one minus 2 pi over 4t into t equal 2 pi. Done. 2 pi cancel. It's common denominator 4t. Here 4t minus t, 2 pi cancel, equals what? Here 3t equal 4t. Then t becomes 4t by 3 is the time interval when they are having same pace of oscillation. Okay, right, done. MCQ question, right? Okay. Let's see. Last one for simple harmonic motion, 62. All the questions should be done, right? We have to do all the questions. Magarin where? Right. Next one, number 62. After completing this one, read the question carefully. And can we use 2 minutes to complete this one? Okay. A simple pendulum has the periodic time T in vacuum. T in vacuum 2 pi root of L over G. Done. What will be the time period of it's completely immersed in a liquid whose density of 1/8? Pendulum completely dipped like this, and this is oscillating of the density of 1/8, density rho divided by 8 here. If this one is having the density of rho, right? Okay, then we have mg and upthrust u. This is also MCQ question. Use 1 minute more. Yes, you have to find effective acceleration for this mass. Difference of this and this vacuum and here effective acceleration is gravitational acceleration, no matter. But here effective acceleration should be different one as upthrust. Then find the free fall acceleration at this kind of position. At here find free fall acceleration. So how can you find the free fall acceleration? Remove the string and let the mass going down. Then apply F equal M. F equal ma downward after removing the string. Free fall, we have weight mg, upthrust u equal ma, m, mass density into volume, density rho, right? Rho v g minus v rho by 8 g equal density rho v rho v cancel here, g minus g by 8 equal a. This is called effective gravitational acceleration. 8g minus g divided by 8 is effective acceleration. It's 7g divided by 8 is effective acceleration. This is effective gravitational acceleration. Right, take this value for the new period, 2 pi root of L over G. G is 7g over 8. This is number 2. Then simplify first 10 seconds to have the final answer. And first 10 seconds divided. T over T dash 2 pi root of L over G over 2 pi root of L over 7g over 8. LL cancel, GG cancel, 2 pi cancel, T over T dash becomes 7 over 8, no? Then T dash is 8 over 7t. As G is decreased, new period should be increased, no? G adu with T value. Okay. A nice question, right? Same general process like MCQ question. Okay, complete this. right? Okay. Let's start the optics part of the revision session. Revision number 1, part D, optics. It is refraction through two plane surfaces. Okay, right. Write law of refraction of two mediums. Write law of refraction of two mediums. It's like this. Here we have intermedium of the refractive index N1, here N2. Light ray hits like this. If this is rare medium and here denser medium, light ray bends towards the normal, right? This is angle of incident, the angle in between the normal and the incident light ray is I. Angle in between normal and the refracted rays R. Then basic theory, we have N1 sin I equal N2 sin I. This gives sin I directly proportional to sin I, which means if you increase I, R automatically increases. If you decrease I, if the rays bending towards the normal, I decreases, then R also decreasing. If you bend this light ray towards the intersurface, I increases, then R should also be increased. They're directly proportional. This is Snell's law, second law of refraction. First law is this ray of incident, ray of refraction, light on the same plane on two mediums, either side from normal. Ray of incident, ray of refraction are placed on two mediums, either side from normal, light on the same plane. That is first law. These two laws should be memorized, right? Okay. Write down the law of refraction. Can you rename that one? Laws of refraction. We have two, no? Laws of refraction for two mediums. For two mediums. Copy the diagram first. At the sideway, we have to draw the diagram and then write first law. Okay, write the first law. Ray of incident and ray of refraction. Ray of incident and ray of refraction are light on two mediums, either side from normal, either side from normal. Either side from normal, light on the same plane, light in the same plane. It's okay. Light in the same plane. Okay, second law. The ratio of sign values, the ratio of sign values ratio of the sign values of the angle of incident and angle of refraction should be kept constant for given two medium. Should be kept constant for given two mediums. Right, that is second law. Okay, then basic theories of this function can be noted down. Let the speed of the wave right here, v1, wavelength lambda 1. Let the speed at here v2, wavelength lambda 2. Then for the basic theory, refractive index of a medium indirectly proportional to speed of the wave. Is speed of electromagnetic wave. All the electromagnetic waves are allowed with this theory, right? Not the sound waves, only electromagnetic waves, especially light, right? Then refractive index indirectly proportional to V, then NV product remain constant for given two mediums, given medium, which means speed changes with the refractive index like hyperbolic curve right here. If V is large, N should be low. If N is large, V should be low. Then we can say one medium N1 V1, the other medium N2 V2 remains same. But Darwani, you should know frequency of this wave. If you consider frequency of this medium is F, that is same as frequency at here. Frequency never change. Frequency of the wave remains same. Then we can replace V equal F lambda. As frequency remains same, V directly proportional to lambda. Here we have N1 lambda 1 equal N2 lambda 2. This is the next relationship. Additional to N1 sin I equal N2 sin R, right? These are the basic arrangement of the refraction. It's very simple thing, right? Okay. Can we complete number 64? No need to copy another diagram. On the previous diagram, label V1 lambda 1, V2 lambda 2. And on 64th one, we have space. Can you write down this whole thing? This one, right? Okay. See number 65. Derive an expression for the refractive index of two mediums with the apparent depth and real depth. Okay. Here we have one medium of the refractive index is N1, right? N2. Here we have position of the object. This is the vertical location of the object. This is the vertical location of the object. This object is seen by an observer on the second medium. Let this one is denser, this one is rare. Okay. This one is the point object. If you consider this angle is very small angle, and the light ray coming closer to the vertical level, this is called the apparent location of the object, right? Then this is apparent depth. This is called apparent shift. Standard symbol is D. This is called real depth, T. Then this is T minus D. Here to here, apparent depth. Here to here, apparent shift. And total here to here, real depth. These are the standard symbols, right? Now, we have to derive the relationship of this and this with the refractive indexes, right? Can we copy the diagram? Question number 65. Okay, then let this intersurface in between here to here is A and here B, right? Okay, then we can say N1 sin I equal N2 sin R for the point of incidence for here, right? Okay, then we are considering I and R very small angles as the observation is made closer to the top view. That is the derivation process, right? Okay. Then sin I nearly equal to tan I and sin R nearly equal to tan R. So you can say N1 tan I equals N2 tan R. N1 tan I. Let's see. This angle is I. This is also I. Alternating angle. This is R. This is also R. Corresponding angle. Then tan I is written opposite base AB over here to here T. AB over T equal N2 is N2, second medium's index. Tan R is opposite base AB over adjacent T minus D, no? Yes. T minus D. AB cancel. It's N1 over N2 becomes T over T minus D. Then you can say T real depth divided by T minus D apparent depth. Not apparent shift, apparent depth. This is the standard equation for any two mediums. And we can say when N2 is air and N1 is N, then we can say N equal T minus T, T over T minus D. This is applicable only for the observation is made by the observer in air. Second medium is air. Object is light in the medium of N. The observer's medium is, if it is air, we can use directly this equation. Okay, right. Note down this one. And rearrangement. This one taken into the other side. T minus D. N2 goes into the other side. N2 over N1. Subject in D. T minus T. N2 over N1. Then D becomes T. 1 minus N2 over N1. This is the relationship of apparent shift and the real depth with the refractive indexes. This is also same for that. When N2 is air and N1 is N, then we have D equal T 1 minus 1 over N. This is applicable only for the observer's medium in air. Observer should be light in air, right? Okay, that. Okay, if you complete this one, can we try question number 66? First semi-essay question 4. Refraction through two plane surfaces. Okay. 66. A person looking through a telescope T just sees the point A on the rim of the bottom of cylindrical vessel when the vessel is empty, like this. When the vessel is empty, looking through the rim like this. This one is the device T. Telescope, he can see the bottom edge of the cylindrical vessel when the vessel is completely empty. When the vessel is completely filled with the liquid of refractive index 1.5, he observes right here. Initially, it is located right here, T. Now, this is completely filled by a liquid, right, of refractive index is 1.5. Then you are given, he observes the mark at the center B of the bottom without moving the telescope or the vessel. He can see only midpoint right here. Then light ray comes from here. This is the normal, goes to the observer's eye. And you are given what is the height of the vessel if the diameter of the cross section is 10 centimeter here to here, 10. They need the height of the container, H. They need H. This is 5, if so, and this is 10. This one is the diagram. Then you can say this is angle of incident, I. This is angle of refraction, R. Then well-known equation, what? N1 sin I equal N2 sin R. N1, this one, 1.5. Sin I, opposite base over hypotenuse. This one is h squared plus pi squared root, right? Pythagoras. Sin I is 5 centimeter over h squared plus pi squared root equate N2 air. Sin R equal to this angle, isn't it, Buddha? Here, that's R, no? Whole angle, this one is same as R, right? Okay, then sin R is opposite base 10 divided by hypotenuse from here to here. We can cover up that one. It's h squared plus 10 squared root, no? H squared plus 10 squared root, yes. Done. Just Pythagoras. Simplify to find h, no? Yes. Here 5, 1, here 2. Then this one is 3 by 2, having h squared plus 10 squared root. And this side we have h squared plus pi squared root, right? Both sides squared. Then here 9 over 4 bracket h square plus 10 square, h square plus pi square, right? Cross multiplication here 9h squared plus 900 equal 4 times of 4h squared plus 25 into 4, no? 100. Okay. Can you simplify this one? Nine, 4, 5h squared equal 800, right? Then h becomes 800 divided by 5. 8, 160 root, no? Root 160. 10 point, sorry, root 160. Take the answer. It's 12 point like that. 64 meters, done.